Hi and welcome to this demo lesson about data ingestion in real time. So typically here we will see an example of an API. So our API gateway that will accept some data that we are producing from a JavaScript application and write all this data to an Apache Kafka topic, or in the second part of the demo to a fallback storage that for the sake of simplicity will be here a local file system. As usual, I will try to show you the Docker Compose, which is very straightforward. We have our Zookeeper and Kafka images and an Apache web server that will read the files from this subdirectory. And the files from this subdirectory are very easy. They represent some pictures of different cities. And the most important part is this collect clicks method that as you can see here will accumulate user activity inside a local storage of the browser. And once there are the batch is full, which means that we have 5 items in the local storage, then we will push this data to the data ingestion endpoint for the given user. So user is hard coded because it's not the point of this talk, but usually it will help us in the data fallback scenario that I will show you later. And quite another important thing is that besides all this, I would say, activity related characteristics, so namely the event time, the user action with the link that is clicked, that he or she clicked, there is also an important parameter which is ID, that is a unique value representing each action. And that's quite important to have this one because it will help you to deduplicate the events later on your customer side, even though your JavaScript application pushes the same data multiple times. So that's something that you should always agree on with your backend engineers. And yes, I think we can start right now. So I will start the Docker Compose. And as you can see, it's our website. So I will open the developer tools and we will visualize here in the network part what's happening between this website and the API gateway that I will deploy just in a second. And my API gateway is a Flask application written in Python. It's quite important to have the CORS to allow different hosts to communicate together. And whenever I start this API gateway, I'm asking the code to create this fallback directory. It's for this second scenario, remember? And later I'm exposing 2 different endpoints. So the first endpoint that we will see in the beginning is the data ingestion without the fallback, meaning that we are supposing to have our Kafka cluster up and running, and we are delivering the data to it by returning the response about successful delivery and eventually failed records. The second endpoint, I will just explain it to you just a few minutes later. Regarding the Kafka part, it's relatively easy because we are creating a producer with some configuration. We have a message holder that will determine whether a message was correctly delivered or not. We keep the key and payload here because if the delivery is not successful, we want to return this value to the client or write it to the fallback storage. And all this is orchestrated with this callback function that we are adding each time we produce a new record. So whenever there is some feedback from Apache Kafka, we will call this handle delivery result, and depending on their error presence or not, handle successful or delivery or failed delivery. So by definition, our data holders are considered as failed deliveries, and only when there are some successful callback, we change the delivery flag from false to true. Okay, so I will just start the API. And you can see that the API is up and running. So now I will do a few actions on this sample website. So I will visit cities, maybe with quite beautiful pictures. So I'm already at 5 visits. Okay, and now you can see that I'm posting. So I'm sending all the events, all my activity to the HTTP endpoint. So you can see that it correctly delivered all the records, and the payload looks like that. And typically my local storage of my browser should be empty, which is the case. If you don't believe me that the data is there, I will just start a Kafka consumer to show you, from the beginning. What are the records produced? So you can see that we have exactly our JSON payload in the order of my navigation, because I visited the pages in the order of links. So typically main page, Paris, San Francisco, Stockholm, and Warsaw. And that's nice because we have all our services up and running. But what if our Kafka broker goes down? So is this scenario that you should always think of with your colleagues. If you do care about the data integrity, because if you can accept some data loss during maybe 1 or 2 hours, the time you have to fix the issue, well, maybe it's not a big deal, but usually and very often you will think about and implement this fallback storage mechanism that I will explain to you just now. So to start, I will uncomment the ingestion endpoint for the fallback storage. So as you can see, it will call a different API. The method, the clicks collection is still the same, but the endpoint will be different. So there is a lot of similarities. We build the same delivery process to Apache Kafka, but here we verify whether the error is fatal or not. What does it mean? It means typically that if the number of failed deliveries is the same as the number of records to deliver, we consider it at a failed delivery. Of course, it's a quite simplified vision, because you could also extend and a little bit enforce this check by, for example, calling the ports exposed by your Kafka broker. But for the sake of simplicity, I'm considering here that if these two numbers are the same, well, it means that Kafka is down, and I should write these records somewhere else into a more resilient storage. And this more resilient storage, it's defined by the SLA. For my case, I'm using local file system for the sake of simplicity, but typically on production you will think about storages like object stores or something that is serverless, and yes, really goes down very, very rarely. And what the code is doing is that it creates a file in the directory I have just created before under this topic partition, and later it writes all the payload and keys to this place. And in that case, we still return this error. Okay, I had a moment of hesitation because the success is true and the failed is false, but success is true because it means that the API gateway could ingest the data to the system, and it does it typically it's a sign for our JavaScript script that the client application can continue collecting new data. So the client application doesn't need to worry about already collected data. It can simply empty the local storage and add new events to it. Okay, now when it's clear, I will redo the same navigation, but maybe I will start by Warsaw. As you can see, local storage changed, but I'm more interested in the network part. I go to Stockholm, San Francisco, Paris, and I will go to the main page again. And now you can see that we are pushing again the data to our endpoint, but this time the endpoint is with our fallback storage. Let's just, yes, you can see that there is data ingestion fallback, and the response is 200, which means that's okay. And now I would like to show you the files, the method, this method wrote. So maybe I will go to the terminal, do a sample 3, PDE snippets 3, lesson 3, fallback. And you can see that we have our data file with all the data inside that is required for the ingestion. And now I will do the same operation. So I will navigate on the website, contact Warsaw, Stockholm, San Francisco, and Paris, and I should create now another file. And later I will show you an Apache Spark job that will take care of reintegrating these failed deliveries to the Apache Kafka broker. Okay, it's good, and now we should have 2 files. That's correct. Okay, so now I will stop this API gateway. I'm not using it anymore, and it will save some compute, and I will open a new fallback pipeline. And before I explain to you this fallback pipeline, I will restart the Kafka broker. And just to show you that there is nothing that happened, I will open the consumer, and you can see that we have the same records as previously. And what about this fallback pipeline? So it's a sample Apache Spark job that reads the files we have produced before and writes them to an Apache Kafka topic. And there is quite important part because you have to ensure that the delivery respects the order of the event time. You cannot take files in any order. It must the process must respect the event time of chaque record, and that's why I'm doing here the repartitioning and sorting within each partition, so that thanks to the repartitioning I have all events related to the same user in the same partition, and later with this operation I simply sorting the user events so that I can deliver them to Kafka topic in order. And of course here I'm using a different trigger available now that runs once and process all data which is available at the point of the execution. So typically here we have 2 files, and the code will process these 2 files. I'm not using a batch API because the batch API doesn't provide this checkpoint location, meaning that I should have implemented it on my own. And you know, we are often lazy engineers, and we like to rely on the things that are already done for us, and that's typically the case. So I will run the code, and we will observe later what happened on the consumer. So the code is running, and the consumer should detect the data that was ingested. Yes, you can see that we have exactly the good order, Warsaw, Stockholm, Paris index, and later we did the same but from the contact page, and we have all the data that is now present in our main pipeline. So generally that's quite so generally I showed you here one of many features of API Gateway, because API Gateway is mostly about data ingestion, right? Because it's the entry point for our data system. But there are also many other important points, namely the security, like authentication, authorization, You may also provide a kind of message validation, so that if someone tries to send you a binary data or something which is not considered as valid from your application's standpoint, where you can simply deny it. Here it's really a quite positive use case that I repeat again, with the goal to focus on the data ingestion, not any other parts. Where maybe you are not the best person to implement them, I think that backend software engineers are more have better skills than you to implement API authentication, API authorization, to implement different optimization methods and things like that. So obviously you will need to work closely with them to implement this API gateway as an entry point of your data system. Thanks for watching and see you in the next lesson.